In this session, we are going to see that half adder and full adder by using the Verilog and VHDL code. So we have to know first understand about the what is binary adder. Addition is one of the most basic operations performed by different electronic devices like computers, calculators, etc. The electronic circuit that performs the addition of two or more numbers, more specifically binary numbers, is called as adder. As we know, the logic circuit uses binary number system to perform the operations, hence the adder is referred to as a binary adder. Depending upon the binary digits that a circuit can add, adders are of two types basically, half adder and full adder. All the higher level number of adders can be able to implement by using the full adder. See, this is the half adder circuit diagram. One XOR gate and one AND gate is enough to implement that. On the right side, we have specified that truth table. So for all the combination, it is clearly mentioned. In the half adder, this is the gate level modeling. So as usual, module name, input A, comma B, and the output sum, comma carry as specified here. Two gates we are using, XOR gate and AND gate. Here the gate level modeling, the U1 and U2 we call it as a instantiation. U1, U2 we call it as a instantiation. Sum and carry are the outputs of the corresponding gates. A and B both are inputs. At the bottom we have specified the corresponding waveform for all the combinations. This is the VHDL code. So not like in Verilog, here we have to use the library and the package, corresponding package. The corresponding default package std_logic_1164.all, and the entity that is used to specify the inputs as well as the outputs. Entity name is port A, B in std logic. A, B are the inputs. In and out are specifying the direction of the IOs. std logic, that is a basic data type we have specified. It supports the 9 level logics. Okay, and end half adder, that is the entity name. Architecture, that is used to specify the exact functionality of the digital circuits. So architecture name of half adder is begin. Inside the begin and end we have to specify the functionality. Here we are using the data flow modeling. The outputs CO and S we have specified in the left hand side, and less than or equal to signal assignment operator we are using. Non-blocking statements, those are non-blocking assignment operators. CO less than or equal to A and B, that is a carry. S less than or equal to A XOR B, that is a sum. At the bottom we have specified that waveform for all the combinations. For the full adder, by using two half adders, that is possible. In this circuit we are implementing two half adders. So one XOR gate and AND gate we are using. In two times we are using for the full adder. Full adder, 3 inputs and 2 outputs. As here we are using the 3 temporary variables for the wire connections. See, this is the truth table for full adder. So 3 inputs and 2 outputs. So totally 8 combinations will come. So this is the full adder program by using the Verilog. So as usual, module name. Inputs, 3 inputs A, B, Ci, and outputs S, Co. 3 wires, that is a temporary variable we are using. So temp1, temp2, temp3. This entire code is related with the gate level modeling only. So how many number of gates we are using actually? Totally 5 gates are using. All 5 we have specified, and the instantiation U1, U2, U3, U4, U5, and final outputs we call it as a CO and S. Those are specified clearly. At the bottom we are specifying the waveform for all the combinations. Here the VHDL code for the full adder. As usual, I said library we are using, and the package, corresponding package we are using. Entity name is port, 3 inputs, and STD logic, that is a data type, and end adder, and architecture RTL of adder, that is a this adder we have to specify clearly. This entire functionality is corresponding which entity, that we have to specify here. So clearly we are mentioning adder, and 3 temporary variable. As usual, data flow modeling we have implemented here, and 5 gates we have used, 2 XOR gate, 2 AND gate, and 1 OR gate we have used. At the bottom we have specified the corresponding waveforms. By using the full adder, we can able to implement the 4-bit adder. Here A and B both are 4-bit inputs, and the corresponding outputs S0, S1, S2, S3. This also possible. And 8-bit adder also possible by using the 2 4-bit adder. Say for example, A and B up to 8 bits. A is the 8-bit and B is the 8-bit. All the 2 4-bit adder we are using, and the corresponding output also we will get it. Okay. And another one way is 1 full bit adder we can use. In such way, in this combination we can use. In the VHDL language, we have to use the structural modeling to implement, to collect all those things, and we can able to use it. Okay.